Welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a part of Gestalt IT. And each episode, we bring you the perspectives and thoughts from a group of IT luminaries, experts in their field. And we have a topic, a premise, if you will, that we like to debate. Before we get into that, I'd like to take a moment for every one of our guests to introduce themselves before we jump in, starting with Tony.
Hey, I'm Tony Mattke. I've been doing networking since Jenko pants were in style.
All right. Eric?
Eric Stewart, University of South Florida. I've been doing networking for 25 years now.
It's just after Jenko.
Yes.
And Aaron.
And I'm Aaron Conaway. I'm at Conaway on Twitter. We're all old. Oh my goodness. We've all been doing 20 years plus in networking.
All right, well, thank you all for joining us. Let's jump into the premise for today's episode. Now, as you notice that we've got a table full of old, grizzled network veterans here, and we're talking a lot about networking. Specifically, we're talking about the way that network has been changed to include a lot of other things. Because, you know, when you think about the network, it should be really simple, right? Packets go in, packets come out in the right location, and everything is great. But not all networks work like that. And we're starting to add a lot of intelligence, and we're starting to add a lot more things that require the network to be a little bit smarter. And one of those things is access controls. Now, you're probably thinking to yourself, wait a minute, Tom, access controls on a network? That sounds an awful lot like a security topic. But that's kind of the way that networking is starting to cross-functionalize, is we're starting to see access controls being put into the network, and we're having to deal with how that works. And that brings up a very interesting point. Where should those access controls be held? Because that's the premise of the episode. You shouldn't be doing network access control at the edge. And we're going to jump right into that topic because I know that all of you have some very interesting thoughts on that. But let's start with, why have we historically been doing network access control at the edge of the network? I mean, isn't that about the worst place you can do it?
Yeah, I'll go first here. It is the worst part, but it's way back in the day. Let's use our age to advantage here. We have some historic context where your switches and routers, all they did was send packets left and right as fast as they could. Mm-hmm. And the only way you could actually filter things was by sending it through a firewall. So you had to ship it out to an edge somewhere and then let that thing make a decision to let that packet go or not. So I think we've kind of stuck with that. That's, 30 years now probably. It's probably older than we are.
So the question that I have there is, you talked about the fact that networks were basically designed, even from their genesis, to be able to move packets as quickly back and forth as possible. So a lot of their intelligence, if you want to call that, was basically baked into the ASIC and the switch. I see the MAC address for this edge node on this port, and I'm going to forward the frame out of that port and that port only. There wasn't a whole lot of time for decision making. And even when we saw that with things like, layer 3 switches, they weren't doing a lot of routing at that time because routing was an order of magnitude slower. And we're talking like 100 megabit Ethernet. And today, the idea of running 100 meg Ethernet would make those people go crazy. But why did we have to route it through a firewall? Was there no way to do that intelligence in the switch?
Well, there wasn't at the beginning. We didn't have that capability because, like you said, we've advanced so much. So we've gone from not even reading the entire frame, like reading just the headers to make it a switching decision, to now we're talking about sampling at 51 terabits per second, getting the whole frame, being able to read all the content. So we have a serious movement forward in the last few years of what we can see at an access port, not ship it out to something and let it read the whole thing, really slowly, by the way, because it takes a long time to put that to CPU and read the whole thing. And so now we have that advantage of we don't have to ship it out. Now we can make decisions way down the stack if you picture your whole core distribution access, which we don't use anymore, by the way, but anyway, that's what we all picture our enterprise networks as. We can still, way down here in access, we can make those decisions, and that's really huge advantage over shipping to an edge because now we don't have to worry about the rest of everything being functional even, right?
Yeah, but it inhibits another problem, right? Now we have singular points of management that you have to have consistent policy across, right? So unless you have some automation, then you're going to be manually updating ACLs on ports for the rest of your life.
Sure, absolutely right.
But I never had automation in the past. My automation was a notepad that I had over here that had like my basic switch config on it. And when I wanted to enable port security on an edge port, I just pasted that line in, and then I hoped that nobody went behind me and modified it so that, oh, well, now you're allowing 3 MAC addresses per port instead of 2. Well, oh, that's going to cause a huge amount of problems in my environment. So are you saying that we can't do this kind of access control at scale without having some form of automation?
I think you hit the nail on the head there. You're talking about scale. That's fine when you have a network person at every location or, even at every city, right? You have a handful of IDFs or more to manage. But, when you have one network team that has to manage enterprise that may be across the US or even global, you can't hire 4,000 network guys. There's very few businesses that can. So we have to have some way to be able to manage that.
And it goes even beyond that. I mean, we're old. We know that the number of users on your network has increased since, every year it goes up. So you have the number of switch ports going up, the number of devices that are coming, and that's the big one for me is, it's all BYOD, so I want to stop them from doing bad things as soon as, they can be identified as doing a bad thing, so.
That's a very unique challenge that a lot of people don't necessarily face. If you're a hospital, you have complete control over your endpoints because they're things that you have bought and you operate. But you may not have complete control over your ability to program them because they could all be IoT devices. Whereas in education and other places like that, sure, we'll just let you bring your Xbox and your PlayStation and your laptop with God knows what on it into my network. Let's just hope that you're not doing anything silly. But how do you manage that many edge switch ports with a policy? Because I don't know who's plugging into that switch port. It could be a student, but what if a faculty member or a hospital administrator plugs into that port? How can I make sure that who they are allows them access to the things that they're supposed to have? Is that a solvable problem at the edge, or do we need intelligence somewhere else to drive that?
You do need some kind of intelligence. I think, we were discussing it in a side channel at some point that nobody's been able to get .1x working the way they would like to get .1x working. But .1x is supposedly the first step. At USF, we're using MacAuth for a lot of things, and that helps. But if you could actually get .1x working, then it's a matter of figuring out where you think you need to employ .1x as opposed to just leaving the port open for use.
I was gonna say, even in places where, .1x is a lot easier, like wireless, right? We're still using a lot of MAB lists, right? Like Mac authentication bypass, because there's no other way to manage those devices.
So you actually bring up a really good point, Tony, that I was going to say. The only people that have successfully been able to make .1x authentication work were wireless companies, because they're not doing .1x. Yeah. They are doing other forms of authentication that leverage .1x to work. And that's great if you have a device with a wireless card in it. But most people don't, especially even if you're dealing with things like IoT. They're headless. I can't configure them. So how can you build a robust system that does admission control, access control, network segmentation, but takes into account the fact that a growing number of your devices are things you can't touch?
Yeah, that's the problem. I mean, you have device enrollment, right? Like, wow. I need a second. What do I think of the endpoint management software? What, like AirWatch, Intune, what are they called?
Oh, mobile device management?
MDMs, thank you. Okay, so yeah, that's the problem. You need an MDM to manage those devices. A lot of people are doing ETLS, certificate-based authentication. That gets you there with wireless, that gets you there with 802.1x. But what about all the devices you can't manage? Like you were saying, you bring in PlayStations, you bring in Xboxes. In manufacturing, people bring in random machines they bought off Craigslist. Hey, I've got this internet-connected welder. That's a real thing. How do you manage those devices? How do you make sure that they're, what they say they are?
I mean, we've been dealing with this problem forever. I can remember configuring switch ports to only allow Cisco phones to connect. Now, I would have to configure the phone to allow laptops and things like that on the back to connect. And boy, in the heady days of when barely any laptops had wireless cards in them, 802.11g, and now look at us. I mean, you can't find an Ethernet port anymore. But that kind of belies that challenge of, doing all this admission control, scaling it to a point where it works perfectly. Does that mean that we need to centralize it? Does it mean that in order to properly do network segmentation, you're going to have a tool like, I don't know, Aruba ClearPass or Cisco DNA Center or something that gives you like this hierarchical view that I log in and I say, okay, well, all of these switch ports have an identity that say student or customer or patient, and you can do X with them unless you see an IoT device plug in. So if I plug the insulin pump into the wrong port, it's not going to be disabled. It's just going to reconfigure the port on the fly. Is that what I'm going to have to start looking at?
Yeah, I think that's a great first step, right? And to expand on that, I think some of the problem is being able to profile those devices correctly. When you start to profile a device with something like ICE or ClearPass, you're looking at a small set of data, you're doing an in-map scan against it, certain things like that. But I think we need more, they were talking about today, Cisco was, about AI and machine learning being integrated into that process. And I think we need some more of that to really make that less of a guess and more of a decision about what this device is.
Now, one thing that we keep coming around to is we're asking something for admission. You're asking for admission with a NAC. You're asking for identification with an AI/ML. So now we're talking about a lot of stuff that we're asking external services for. Now you talk about at scale. I don't know how many switches you got there, Eric, but I don't have nearly as many as you do, I promise. And it's unmanageable for me just to go and log into them and configure this stuff. So I need some automation at least, but now we're really talking about controller-based stuff where it is the word of God over all of your network gear, including your wireless, including your wired, things like that. And it can do the querying to the external services to make those decisions for us. So.
But the challenge there, we'll talk about this brown elephant over here in the room, is that I don't operate a brand new, perfectly pristine network where I just unboxed all of my devices and turned them up to run them.
Oh, no.
I know. Everyone keeps telling me, well, in a perfect green field, this will just work. I'm like, when's the last time you saw a perfect green field? Mine looks like my front lawn in Oklahoma in July. It's brown and crusty and disgusting, but it's my lawn and it's my network and I have to deal with it. So can those two things coexist? Is there a way for me to program a centralized access control policy enforcement method and then distribute it to the hodgepodge of gear where I don't have a Cisco 9300 or a Juniper 4400 running in every stack of every closet like I want? The arts department still has that old 3750 that may or may not be on death's door, but we're going to run it until it dies. Can I make those two things work together?
So the first part of your question, I honestly don't know. We've been trying to implement .1x on our wired environment for several years. I've seen a lot of other people doing the same thing, running into the same issues. And when you talk to experts in the field, the answers you really get are about a greenfield environment. That's what they want to see. That's what they want to work with. And it's just not the reality. As for being able to interoperate with older gear and things like that, I think that comes into more manual policy that has to be implemented for those. Those have to be considered one-offs, in my opinion. Same thing with even putting a Cisco AP in. You can't run ICE on that port. Unless you're going to apply policy to all the wireless clients, if you're running in direct access mode, right?
I think there's a point at which you've got to go, we want to be able to do it in the future, so as we replace equipment, you can get away with it. But you're going to have to deal with the old stuff until you get rid of it, and until your replacement cycle occurs. Once you're at least you know, a good way into replacing all your equipment, then you really should have .1x and MacOff MacOff in place wherever you can, and, you know, deal with the one-offs when you have to.
Is it acceptable to have, to wait for a full cycle? Because we all know our 3 to 5 year cycles are 7 to 9 years, right?
Yeah.
So it's really going to be a decade almost while we wait for the last thing we bought that's not compatible to actually be compatible. I mean, that's a business decision. I imagine, you know, it depends, right? I think healthcare, education, those are, they'd probably get away with it a little more. If there's something that has a benefit for my company, there's going to be an effort to get it refreshed until I show them the bill for however many millions of dollars to replace everything. And now the whole project stops, right?
Yeah, there has to be a risk analysis, right? You know, there's a cost to every decision you make, and there's a cost to every thing you decide not to implement, right? And that cost is, you know, how much risk is there, you know?
Maybe that's part of the answer to this is we've been so focused on things like hardware that we've forgotten that we don't do hardware networking anymore. I think it's software. With software-defined networking, intent-based networking, networking-based networking, whatever you want to call it. We've been changing the way that the network performs. We hinted at it at the beginning. You know, we're not just switching packets as fast as possible on the edge anymore. We're moving them around. We're doing a lot more things with them. We're doing operations on them. And typically those kinds of software programs run a whole lot better at what we used to call the distribution layer, or maybe now it's the spine nodes, or maybe the switches in those environments are fast enough to shuttle them off to have a decision made and bring them back before they have to be distributed to wherever they're supposed to go. So could it be that the best argument for not doing policy enforcement and network segmentation at the edge is that it's better handled by a device that has more horsepower that can make better decisions, and all we're just hoping for is that the switches at the edge of my network forward the packet to a place where they can decide should it go on any further than this?
Well, I mean, that is a valid model. That's what we're using now, and we'll probably still use it for a long, long time. But there is another risk there is that the transit between the endpoint, like the Xbox that someone brought in, and the firewall that's doing the filtering, what are you going to do about that when that thing starts infecting every Xbox that's on your network? Right now suddenly you have 10,000 nodes that are infected with something instead of one that could have been prevented by filtering that at as far toward the edge as you can. So, I mean, so that's the risk there. But yes, we will have that for quite a while, I'm afraid.
So what if the answer to this isn't related to hardware as we know it, or software as we know it? What if it's a revolution in the way that we do data processing units? We see them in servers now. They're offload engines for I/O. They're little ARM processors that can do a lot of really cool stuff. But we're starting to see them deployed in switches too. We're adding intelligence at the edge, and not just the kind of intelligence that's baked into an ASIC that was built 5 years ago and we can't modify. It's the kind of intelligence that's programmable on the spot. So now I can change the way that the packets are forwarded out of my switch without the switch even knowing that, because they're all being forwarded through a DPU where the decisions are made. In essence, what you can do with that technology, whether it's made by any manufacturer, once you have support for those DPUs, is you can effectively turn all your switches into a switch fabric. Because now you have intelligence in the switch that allows it to be a part of a fabric without realizing it. So could it be that the way to do this, as we kind of discussed right before we started, is not to do policy enforcement on the edge of the network, but to do it in the network fabric, because the fabric is everywhere?
Yeah, I think I agree. We just need the technology to catch up to our expectations, I think. It's part of the problem.
I don't really know. Are we there and just don't do it? I mean, that's the question we got to figure out. What do we have? What are the maximum capabilities of what we have here versus what we wanted to do? Like you're saying, I think we all agree. I mean, it should be dropped as soon. A packet should be dropped as soon as it can, right? If it shows up on the switch port and it's something that's malicious, it should be dropped right there. And that needs to be controlled by something like the fabric, like you configure the fabric versus configure your edge. But I don't know where we're really at. Has anyone actually done anything like that? Or close to that, or even read about it?
It sounds like we're talking a lot about like security tags and some of the things we were talking about earlier, with that presentation, but.
Kubernetes everywhere, right?
Yeah, exactly. Yeah, that'll solve everything.
So as you can see, there's a lot of challenges in how you need to do network segmentation, about how you want to do access control, about how you want to make your network smarter and make better decisions so that it scales better with a small team, that it provides the kind of value that your users are expecting to see, while also respecting the fact that we don't have an unlimited budget to just buy new stuff to make this work. And these challenges are the things that we have to figure out. We, as network folks, have to look to the future to decide, should this switch be the one that I buy because it has the intelligence, or because it can join a fabric where I have the right software setup in order to build this idea further so that I can effectively become a force multiplier. And, we didn't even talk about it today, but this all makes a whole lot of sense when your packets are flying back and forth across your network. But what if they're all headed out going somewhere to the cloud? That can absolutely change the recipe for what you want to put together. But the key is that you need to start thinking about it now. Because if you haven't already, the next time you're coming up for a refresh cycle, it's going to be something you're going to have to think about. That'll just about do it for this episode of our On-Premise IT podcast. Thank you very much for tuning in. We have a new episode out about every 2 weeks. If you want to see the latest episode, you can head over to gestaltit.com/podcast. You can also follow us in your favorite podcatcher of choice. You can also subscribe to us on iTunes. And no matter where you listen to us, we'd love it if you would leave us a rating and a review. That helps people understand what we're all about here, enterprise IT with a good premise, and maybe get us a few more viewers. And if you have a premise that you'd like to suggest for the podcast, make sure you tweet. We're at On-Premise IT on Twitter. We will be back with another great episode in a couple of weeks. Until then, remember, stick to the premise.